All right, today is part 3 of the Filter Fundamental series. So if you have not watched part 1 and part 2, please go ahead and pause and do that. This part 3 picks up right where we left off with part 2, so it's obviously critical to watch part 2 first, and of course part 1 as well if you're not really familiar with filtering terminology. There was one question that was really good on the last one is, hey, why do we have this gyro hardware filter if it adds so much delay? And my answer is it really that much delay? If you look at it, the hardware filter in the gyro is 0.97 milliseconds of delay. And you could see the data in the part 2 video of what 32K noise, how much amplitude and frequency of noise that was versus 8K mode. You can see 8K mode was a lot cleaner coming from the gyro trip, all for 0.97. For us to have a filter, a biquad filter at the same 250 hertz cutoff is about the same amount of phase delay. So the question is, could you switch to 32K mode and just have one additional biquad filter at 250 hertz and get the exact same results? It's a good question. I haven't actually run that analysis yet to see if it all equals out. But you can see anything lower than that, so at 200 hertz for a biquad, it's more phase delay, and even switching this to PT1, that would need to be down to around 180 to have the same equivalence, or up to 180. So if you'd have this down around 100, that would be actually more phase delay. Okay, with that, let's get into part 3. So in any filtering regime, what we're doing is we have the gyro has some hardware filtering built in. No matter what mode you're in, it's just how much. In 32K mode, it has kind of, I would say, a little bit of digital low-pass filtering going on. You can see the amount of noise that comes through. For 8K mode, it has more. It has about 1 millisecond latency associated with that too. Then there's usually filtering applied on the gyro signal itself. So that will be filtering that. Then the P, I, and D term, all the PID values, won't see any of that noise because the filtering's there on the gyro. And then there's some additional filtering, just because D term is such the bad boy, that we want to counteract really that bias towards doubling of amplitude with doubling of frequency. That's where the D term filtering comes into play. And you can kind of split the load too, right? So you could say, well, I'm going to let a little bit more through on the gyro, and then I'll just apply a little bit more on the D term. So instead of delaying the P term and the D term with gyro filtering, I'll just kind of split that, and the P term will have less delay, but the D term will have a little bit more because I'm going to put more bias here. So you can kind of thread that needle there. To me, it's usually half and half. Usually about whatever your gyro latency is, usually have about 2 milliseconds here, or 1.5 milliseconds here, and then 1.5 or 2 milliseconds on the D term total latency. Okay, now back to the firmware. So the higher you have their D gains or P gains, the more filtering you will need. So everything's a trade-off. I wish it was simpler, but it's just not. So if you want, higher P and specifically D gains, you are going to need a cleaner signal. If you're going to have lower D and P gains, then you could probably let a little bit more noise through. Now, on the flip side of that, D gains and P gains are needed to counteract prop wash. So if you go too low, it's going to feel real sloppy, and your prop wash is going to be horrible. If you go too high, your motor's going to get hot because you're going to have all that vibration and amplifying of the noise on the gyro. So in FlightOne, there's a little bit of, I don't know if it's a drawback, but you're going to need to go more by feel. There's some people that can get logging to work, but I could never get logging to work. I know FlightOne is working on Falco. It's a whole different firmware. They're kind of starting fresh, but until that's released, and I'm not sure if that's going to have logging or not, you can't see the data. You're going to have to kind of go by feel, and you do have these presets. So my recommendation for setting up your filtering is just to first check out these presets and see how they fly for you. Obviously, I would start on default, then you could go to high. So this is high filtering, and then go back down to medium, and then low. And you can see what it's doing here. It's kind of moving these cutoffs up as you get less filtering. Now there's a couple options you have. So in the gyro smoothing, from what I understand that will do is it will actually take less samples, so you won't get the 232K sampling, which one of the biggest things that bugs me is people think faster speed is, the more samples is faster. We need to get beyond that. It has nothing, you saw, it's 0.1 millisecond differential between the speed. It has nothing to do with the sampling. It has to all do with the filtering, that digital low pass filter, and saving that 1 millisecond for 32K, if anything. So in this one, with medium, high, and very high, from what I understand, that will take every other sample and average it before it passes it into the filters here. So that's one option. You can play with that. Again, I wish I could run data to show you the effectiveness of that or not, but I kind of can't at this point. And it's also, it is a real shame that the logging doesn't work, because in FlightOne you have the option here, which is unique, to adjust the filters per axis. So if you have a really noisy yaw axis or pitch axis, but the other two axes are fine, you could have a little bit tighter filtering and looser filtering on one axis to the other. But I have no idea how you would figure that out without running some logs. So for now, I would just set these all to be the same until hopefully logging can be made to work. Taking a look through some of these settings, definitely give them a try. I would do things a little differently, so I'm going to give you my 2 cents. And if what I say, if you try it and it's like, UAV tech, that didn't work, that's fine. Then use these other ones. This is just my 2 cents of the stuff I know about filtering. So let me outline some logic here of how I get to my recommendation. So what should you have going into this? If you can run a log, you can look at this on your quad, and I don't know how you would do this without a log. So for FlightOne, if you are on FlightOne, you do have the option to flash to Betaflight, run some logs on your filtering to get an idea of the machine, your raw bass noise and stuff, and then flash back to FlightOne to kind of set some stuff up. So that's an option. It's kind of a pain. You could do that. Obviously, if you're in your Betaflight, you can look at this, or just kind of get an idea of my recommendations here. Your motor noise really is from around 200 hertz, 230 hertz, up to, for a 5-inch quad, up to, I would say a max around 600, 610, maybe 650 at the most. That's your motor band. If you have noise between, let's say 50 to 200 hertz, you shouldn't have noise in this band. If you do, you really have some mechanical issues. You have a frame resonance or other things, and you might have a brand new frame. I got a secret. All premium frames aren't awesome when it comes to noise attenuation. FlightOne, I have the Nova. That frame looks great. So does a $20-some Martian 2 frame from Banggood. That's a pretty good frame for noise attenuation. I haven't been all that impressed with Rooster and Chameleon. There's some other frames as well. So just because you have a premium frame doesn't mean they're great noise-wise. Now, on the Chameleon and the Rooster side, say, well, he's really bashing on those. Like, well, no, they replace those parts if you break them for free. So that's a big upsell onto them. They're very rigid and strong, but hey, noise attenuation-wise, just the logs I've seen. So anyways, if you do have noise in this band, you should try to fix it mechanically. All my recommendations are really coming understanding that you have a pretty well put together and you don't have weird resonance frequencies between, say, 80 to 200 hertz. You kind of see this pattern here where it's, spiked up high, this is your prop wash, drops down to about 200 hertz, and then it starts picking up, and this is all your motor noise. So with that, if we go into our fancy-dancy graph here, we can see, well, what do we got here? So this is the filters individually. This is the attenuation. I'm not going to get into all details. You can play with the sheet if you want to or not. Just keep track of this red line. You can see this is 200 hertz, this is 300 hertz, around 250s right here, and you can see we're really getting some, this is zero noise down here. This is the attenuation, or how much amplitude would be let through. So half the amplitude would be let through here, and you're getting down to like you're below 0.1 of the amplitude. So in this filter recommendation, we're really focusing from this spot up to really just crush the noise. That's what we're really looking to do. You can notice the difference on here between a PT1 and a biquad. So if I change one of these filters to PT1, notice how that has a 150 cutoff, but you can see it's a lot more laid back up top, and it doesn't attenuate nearly as much here. I don't love first order filters like the frequency filter or the PT1 filter, they're just not very strong. If you do have frame resonance, down in that 80 to 200 hertz range, a PT1 may be your best filter there though, because it kind of broad brushes that noise and gives you some attenuation broadly from, you can see here, from 50 hertz, from 40 hertz up across. I'm more of a fan of biquad. PT1s are nice because they have very little latency compared to a biquad. So you can see this is 1.1 milliseconds, and as I change this to a biquad, that's going to jump up to 1.5, so it goes up 0.4. That's, to me, that 0.4, but then you can see it attenuates a lot stronger after the cutoff. So I really like a filter setup for you to try is on FlightOne would be a biquad on low pass 1 and low pass 2. So we're talking stage 1, stage 2. You'd set this to biquad. And in the essence of time, I've set up the rest of the screen. So you would do a biquad 150, biquad 230. Again, we're trying to be right below that where that motor band and the noise level starts to incline here. So we're trying to get these set so the cutoffs are down here right before this starts to increase in amplitude for this motor noise coming in. And then again, the same settings on the D term. You'd go out and fly that. This is going to very much be a feel thing. If it flies all right, and you're kind of liking it in prop wash moves, the motors aren't hot, go ahead and try to bring up the lower or the stage 1 low pass filter values. So you'd bring these up to say 175 or 200. Same on this. I would actually start to raise the gyro ones first more than the D term ones. It would leave these a little bit lower. If it were me, honestly, I would do that with the filter calc tool in hand. You can see we have a latency of 1.5 or 5.1, which it's okay. But as we raise up the gyro 1 low pass filter and the D term low pass filter, you can see to 200 and 200, then that latency goes down to 4.4. So now it's getting pretty competitive, and you can see the attenuation differences up here as you're playing around with that. Again, here you can see with that filter regime on the D term how that is really suppressing this natural reaction for the D term to double with frequency, and that's really starting to kind of counteract that around 200 hertz and kind of bring that back down. And then up at 500 hertz, it's almost equivalent to what you would get at your normal operating frequencies, your control frequencies for motion. I would say if you can keep working it and keep raising up these low pass filters for prop wash tuning and whatnot, what is a good value? 4 is a good value. Honestly, I'm at the point right now I want to be at like 3.5 or 3. I really want to get these down. It gets a little tricky because there's stuff to deal with. It really all depends. If you have a super clean mechanical machine with good props is a huge part of this, then you'll be able to get that done. So you can just kind of keep moving those up, and it's kind of trial and error. You got to play with it. With some logs, you could probably visualize things a little bit better and see what you're doing, but that's just not an option at this moment. Okay, so for Betaflight, what do we want to do there? Well, the first thing we want to do is make sure the dynamic filter is enabled. Next, we're going to go to the PID tuning tab and make sure that the filters here are turned on and enabled. They should be, I believe, in Betaflight 4.0 at least. They'll be defaulted at 150 biquad, 150, 150 here as you see. Now, Betaflight's a little different. Now we have that whole 32K, 8K mode coming into play, right? So you got to pick which one. So in 8K mode, you're going to need less filtering because the gyro is doing it internally. And that's, again, the argument. From what I've seen, the gyro is doing a pretty darn competitive job for how much latency you're getting. It's doing a pretty good job of filtering out the noise. But in 32K mode, it drops that off. We can do a pretty good job too. So I don't want to tell you which one. You figure it out for yourself. See what you like the best. I'm still honestly testing back and forth, trying to give everything a fair shake myself. In either mode, we want the dynamic notch to handle all the motor noise peaks right here. In 8K mode, we then don't really have noise above that. So we don't need any filtering up here. Just the low pass filtering we'd have down here would take care of any reminiscent noise. In 32K mode, however, we are going to need a filter. So in 8K mode, what you really want to strive for is a single low-pass filter on your gyro. No low-pass 2. We don't want him. He has too much latency. We don't need you. We do want to have, at the start, at least 2 D-term filters. And what I'm going to specifically talk about right now is Betaflight 3.5, point whatever, 3.5.1, 2, 3, 4, 5. The game is going to change here, folks, with Betaflight 4.0, because in Betaflight 4.0, these low-pass filters, low-pass 1 and low-pass 1 over here on the D term, are dynamic. So as you ramp throttle, they're automatically going to move up with the motor band, with the motor peaks. In Betaflight 3.5, that doesn't happen yet. So let's just focus on static low-pass filters. So in 8K mode, this is the settings I would recommend to start with. 150 biquad, 150 biquad, and 200 here. In Betaflight 3.5, this is a PT1 filter, the D-term low-pass 2, and you can't change it to biquad. In 4.0, it's going to be default as a biquad, and you could change it if you wanted to. But for now, so that's why we're going to have this a little bit lower here. Ultimately, what you want to try after you fly this and you have the dynamic filter turned on is you really want to get to a spot where you can turn this off. And then at that point, work to move these values up. These are low pass 1 values, so those are the ones that have the biggest latency reductions as you move the cutoffs up. And you can see that here in the filter cap tool. As the cutoffs are higher, so this is 200, 230, you can see the latency is less. So as I move this one up, I'm going to get less latency. And it's a trade-off. It depends, how high can I move that? I don't know. What's your base noise? What kind of props are you using? If you're using really junky props, you're probably not going to be able to run it very high. So spend an extra couple bucks and get some really decent props. And if you don't know what props you should buy, I did a video, which I'll link to upper right, for the ones that had the best performance, because you want clear props as well. See, it gets all kind of complicated. In Betaflight, if you were running in 32K mode, I would just simply enable this low pass 2, set that to 650 around, because that's at the end of where your motor peaks is, and that's kind of the top end range for the dynamic filter for a 5-inch quad. It can go higher for a micro if you set it to high mode. Yeah, set this to 650 biquad, and that's where I would start with. Again, focus all your attention if you want to tweak it out, realize how much you want to play with it. Raising up the low pass 1 filters, not so much these low pass 2s. You don't really get that much latency reduction by moving those up. These settings should work for 5 inches or for micros, because micros, the motor band actually goes higher. So instead of around 600 hertz, it tailing off, and right about here, it will actually go up to 800 or 1000. You can see that will go. You'll see that peak go up into here at 900 hertz. So it's just kind of longer. So these, luckily, as the noise is higher in frequency, these low pass filters down here attenuate stronger, so that helps you out there. In Betaflight 3.5, there's a couple notch settings. There is a dynamic notch quality factor and a dynamic notch width factor. So you'd have to go into CLI. If you type get DYN, you'll see those. The default is 70, and I believe the default width is 50. A more aggressive dynamic notch on that would be to change this to 40 for width and change this 70 down to 5. 5 will open up the range of the dynamic notch, which I would definitely recommend. And again, the width, I don't think 50 gives you more filtering, but I think 40 gives you more competitive latency there, and I still think she'll be working pretty good for you. Again, everything's going to kind of change in 4.0 in this regard, and if you're interested in 4.0, I will make a link to this video that goes through all the little nitty-gritty details of the dynamic notch in 3.5, and this video that has all the little gritty details of Betaflight 4.0 and the dual dynamic notch that has in the nightly builds already. Okay, so with that, hopefully with this video you have some idea of where you want to focus your attention. I gave you some of the settings I would give a try. FlightOne, you do have those awesome presets, which I really wish Betaflight would have. So for some different filter setups, give those a whirl. It's kind of a feel thing, feel your motors kind of thing, and maybe give my filter settings a try as well. Betaflight, same thing, because these are not the defaults. These will be the defaults for Betaflight 4.0. So it's an evolution there as well. I really do wish I could just give you magic settings that just make your filtering world, come together. But it's so variable. Honestly, the only way that filtering will be, one click and done is it has to be completely dynamic. And I know Betaflight's working towards that. There's going to be RPM filters coming out that reads the telemetry from your ESCs, like the 32-bit ESCs. There's a couple catches though. First, you have to have 32-bit ESCs. So if you have BL-LES, sorry. So you'll still have the classic or the current Betaflight dynamic notch. This RPM thing will be an option. And I know FlightOne is working towards a whole new firmware from the ground up, and I'm sure they'll have some amazing things in there as well. Watching some of the flight videos already, it really seems impressive how that's flying. Just to recap, you really want to try to have no or not a lot of noise in between where your prop wash leaves off around 60, 70 hertz up to around 200. If there's a lot of noise in there and it's a 5-inch quad or higher, or a smaller, like a 2, 3, 4, up to a 5-inch, when you got into a 6, 7, 8, 9, 10, 12-inch quad, those frequencies are going to move down. So what I just said there is kind of not valid. There might be in the 150 range, but if you do have some stuff down in that range, you should really look at your mechanical and see if there's something you can do there. If not, then you're just going to have to lower your filters a little bit, which kind of stinks because the latency goes up and it's not that great. Normally, you would focus all your attention from like 200 to 230 hertz up to around 600. Try to really maximize the amount of filtering and attenuation. You can use this sheet to keep track of this red line. You really want this to be flatlining down here from that range up, so it's really killing all the noise, and then it's just a trade-off. How much can you move these low pass 1 values up to reduce the latency and still have good attenuation? You can see it through your logs or just motor tests, things of that nature. You can get dramatic with moving your filters up as long as your motors aren't getting hot. If you get some bent props, that might go awry. The other thing that comes into play is if it's too high and your D term has too much noise built into it, I think your prop wash handling is going to go down. So high, if you can, filters are just like the porridge. You want it to be just right, not too little, not too much. If you go too high, again, as you're evaluating your filters, make sure to be doing prop wash moves, going back and forth, and just play with it, move stuff up. You can use your OSD elements to do that kind of stuff in Betaflight. I'm not sure in FlightOne, you can connect and move stuff up and then go do prop wash. To me, it's all about prop wash and see what works best for you for filter settings there. It does have a dramatic impact on prop wash and I guess feel. I'm not so convinced on the feel part, but I know it has to do a big difference on prop wash. Okay, everybody, thanks again, and I hope this helped.